If you want me to explain it a different way, you tell me, but I'm just going to do it the most straightforward way I know. I'm going to start with these. I'm going to look at the slope of this. That's going to tell me which one of these it is. Then I'm going to look at the slope of that one, and that's going to tell me which one it is. So the slope is 0 whole time. That means velocity is 0 the whole time. This is the one right here. So J. Slope of this is 0 the whole time, which means the acceleration is 0 the whole time. So L. So it's J and L. And then for B, slope, it's positive the whole time. I look for an acceleration, or sorry, velocity is positive the whole time. That's I. That's the only one. And now look at this. Look at the slope. Slope is 0 the whole time. So an acceleration that's 0 the whole time is L again. So these have the same acceleration. They're different velocities, but the same acceleration. Acceleration is change in velocity. And here, velocity is not changing, 0 change. Here, velocity is not changing, 0 change. That's the same acceleration. The acceleration is 0 in both cases. So now for C, the slope is negative. Same negative slope the whole time, so I need to look for the same negative velocity the whole time, and that would be G. So G is this. And then to figure out the acceleration here, I look for the slope, which tells me how velocity is changing, and it's not. There's 0 slope, which means 0 change in velocity, which means, again, the acceleration is 0. So it's L. So these first three, this, and this, they all have 0 acceleration. 3 different velocities. This one's moving to the right, this one's moving to the left, this one's not moving, but none of them is changing velocity. That's why they're all flat. So that means all 3 of them have 0 acceleration. These two, the ones with the curvy position graphs, they're going to have acceleration. So I look at slope. Slope is positive, going uphill. Slope is 0. Slope is negative, going downhill. So I need to find a velocity that starts out positive, goes to 0, and then goes negative, and that's this one. So this one goes with D. And now I look at the slope of this, which tells me how the velocity is changing. The slope is negative, which means I'm losing velocity. And it's the same negative the whole time, so I look for an acceleration that's the same and negative the whole time, and that's K. So K. And then E, look at the slope, downhill, negative. The slope is 0, it's flat. The slope is uphill, positive. So I'm looking for a velocity that's negative and then 0 and then positive, and that's this one over here, that's F. So F goes there, and then the slope of this is always positive. We're always adding to velocity, so I need an acceleration that's always positive, and that is M. So the answers were JIGHF for velocities and LLLKM on the bottom. A little weird that all those constant acceleration ones were at the beginning. I just scrambled them randomly. They turned out that way. Now for this one, get the screen going again. This can be one of those days with the screen. Where's 209? It's not even showing up. Oh, there it is. So the acceleration formula is the bottom one up there. That's the one you need. Acceleration is change in velocity over change in time. And we've got somebody who's running up a hill. You know, you run up a hill, you get slower, unless you just work your butt off to maintain the constant speed. So 5 meters per second, does anybody know, is that fast or is that slow? Well, at some point, I want you to know what a meter per second is, but this is about 11 miles per hour. Is that fast or slow? Yeah, 10 miles per hour would be a 6-minute mile pace. So this is running faster than a 6-minute mile pace. But then when they start going up the hill, they slow down to this, which wouldn't be 3 meters per second. That's more like a 10-minute mile pace. So they're slowing down that much over 4 seconds. That's not important. That's just giving you a picture of what's going on. So change in velocity. Can you stay outside for a little bit longer because we're going over the quiz? I'll have you take it in just a minute. The change in velocity is final velocity minus initial velocity. So it's 3 meters per second minus 5 meters per second. And the change in time is 4 seconds. And here's where a lot of people messed up. What's 3 minus 5? -2. So the acceleration is a vector. We need to make sure if it's to the right or to the left, we acknowledge that. So this person's running to the right, but their acceleration is actually to the left. It's going to be a negative acceleration. That's what's slowing them down. And it's probably the gravity of the hill causing that acceleration, or maybe just a choice. Anyway, this is 4 seconds, and this comes out to -1/2 or -0.5 meters per second squared. I didn't take off for units again. At some point, I'm going to want you to have the right units. So try to label things with the right units for now. And this, if you didn't have the minus, it was just -1/4 of a point. So the scoring, this was 1 point, 1 point, 1 point, 1 point, 1 point. So each of those parts is a half. Any little X you have up here or mark, that's a half a point. And then down here, this whole thing was 1 point. So 5 for the top, 1 for the bottom. And if you retake this, it'll be the same. Now, instead of figuring out change in velocity using the formula, you can just ask yourself, if I'm going from +5 to 3, am I adding or subtracting? I'm subtracting. So that's how you know it's negative. But don't forget to have the right sign there. It is important.